Can you buy $7.94 at the price of 4.7? No. I have to buy 2,000 or more to get the price of 4.7. That's what the price schedule says. That's what the graph says. So, no, it's not feasible. No, it's not feasible. If it's not feasible, because it's not greater than 2,000, then I will have to use the price break quantity. Use price break quantity, which is the smallest quantity you can use, smallest possible, at this price, to calculate TC. So we're going to use TC at the quantity of 2,000 because that's the lowest price. Now we're going to have to use the entire TC for these type of problems. So let's write it out here. TC is going to be the holding cost, Q over 2 times H, plus D over Q times S, plus P times D. So now, in addition, we're adding the purchasing cost because P is different. So this is my total cost equation in a quantity discount model. And because P is different, we're going to add P in this equation. So we substitute 2,000 for Q divided by 2 multiplied by 1.41 plus demand is 8,900, Q is 2,000, multiplied by 50 for S, plus the price is 4.7 multiplied by 8,900. So if you multiply, add, you get a total cost of 43,463. Okay, so we continue. We go to the next step at P equals 4.8. So if 4.8, H is equal to 0.3 times 4.8, which gives us 1.44. Let's calculate the Q at this. So 2SD over H under the square root. So 2 times 50 times 8,900. The top part, the numerator stays the same, but the denominator changes because H depends on P. And we get 786 units. Is 786 units feasible at the price of 4.8? Can I buy 786 units, 786 units, at the price of $4.80? The answer is still no, because 786 units is not between 1,000 and 2,000. So the answer is no. So that means I go and calculate TC at the smallest Q, price break quantity that I can buy at 4.8, and that would be the 1,000. So I go and recalculate the total cost, but this time I use the quantity 1,000 plus 8,900 divided by 1,000 times 50 plus 4.8 times 8,900. I get 43885. So the idea is you're going to keep going up the steps until you reach a feasible EOQ. So keep going. So now we go to the next step, which is at P equal 4.9, which gives me a holding cost of 0.3 times 4.9, which is 1.47. Okay, so now let's calculate the EOQ quantity for that. That's 2 times 50 times 8900, but now I divide by 1.47, and now I get 778 units. Is 778 units feasible at the price of 4.9? Yes, because 778 is between 500 and 1000. I can buy it at this price. So this indicates now that I can stop going up the steps. Once you reach a feasible EOQ, you can stop. So now you go and you pick the absolute minimum TC from all the TCs that you have calculated so far. So which ones, we still have to calculate the TC at this feasible quantity. So before we do that, let's calculate the TC at this feasible quantity. So let's scratch that. TC at this feasible quantity at Q equals 778, since it turned out to be feasible, is equal to 778 over 2 times 1.47 plus 8900 over 778 times 50 plus 4.9 times 8900, and we get 44754. So now we find the absolute minimum TC. So TC minimum is the minimum of all the TCs we calculated so far. How many did we calculate so far? Well, let's see. We had one we calculated here. That's one at 2000. One we calculated at 1000, and one we calculated at 778. So if we find the minimum of these three, 43463, 43885, and 44754. So what is the absolute minimum? The absolute minimum is 43464. So then the absolute minimum total cost, TC star, is 43463. That's your optimal total inventory cost, annual inventory cost. How did I calculate that? Which quantity did I use to calculate this total cost? So I have to backtrack and see, this is my optimal cost. What quantity did I use to calculate that? So I backtrack to see what quantity I have used to calculate that. Well, it looks like I used Q equals 2000. That makes this Q the optimal Q to order, 2000. And so this is my optimal quantity to order. So every time I place an order for seeds, I should be ordering 2000 seeds. If I do that, then I minimize my total annual inventory cost of holding, ordering, and purchasing. Any quantity I order more or less than 2000 will increase my total cost. Now, as for the reorder point, if we were given a reorder point, we will do it exactly like the other problems. The reorder point is little d times lead time. So little d is the daily demand. So if we have 365 days a year, then we take the 8900 per year and divide it by 365 days a year. So if we have 8,900 and we work all 365 days a year, that will be my daily demand, and the lead time is, say, 3 days, then I will do 8,900 over 365 times 3. And that will give me about 73, and that is also in units. So basically, anytime my number of units drops to 73 units, I reorder 2,000 units. That's how it goes. And so my cycle would look something like this. Here is my cycle, the cycle that you're used to in the book. Here is time, and here is your quantity, and this is 2,000, and you order and you use it, and then you replenish, order, replenish, and so your reorder is 73, and so here is what you leave for your lead time. So basically you're at Q star here, and this is your R star here, or reorder point here. So when you drop to 73, then you place an order for 2,000. You have enough to cover you during the lead time. Then you go back up to 2,000, then you use, and when you drop to 73, you reorder again 2,000, and this cycle repeats itself.